In this problem, we have a load P, which is acting at point D on this disk. What we want to do is calculate the moment of P about 3 points, A on the bottom, B on the right, and O the center of the disk. In each case, we're going to use the vector approach of doing R cross F. The first thing we want to do is write the force P out as a vector. So I'm going to first talk about this angle of theta. And theta is such that when I look at the picture, sine theta is going to be equal to 5 divided by 13, and cosine theta is going to be 12 divided by 13. For part A, as I calculate the moment about point A, I do R cross F. So I go to the R vector, which goes from the point about which we want to know the moment, and that's A, to the point of application, which is D, and cross that with the force which is acting there at D. So going from A to D, we go R and the minus X, we go R and the positive J. That gets crossed with the vector there, P, and P, which I was going to write down but forgot to, so let me write it down here. P is going to be equal to P sine theta in the I and minus P cosine theta in the J. So that load therefore becomes 5 over 13P and minus 12 over 13P in the J. When I cross these through, I see that I get no contributions from I cross I, but when I do I cross J, what I'm going to get here is a 12 over 13 P times R. And that's with a plus sign because we have I cross J is a K and the two minus signs become a plus. The second one is going to come from J cross I, and that's going to give us 5 over 13 P times R. Keep in mind that J cross I is a minus K, so I put a minus sign there in front, and this becomes um, what did I say that is 12 minus 5, so that's 7 over 13 P times R in the K direction. Do the same thing for looking at the moment about B, but here the R vector is going to go from B to D, cross with P, and when I go from B to D, that's going to be minus 2R in the I direction, cross with P, and P we saw was equal to 5 over 13 PI minus 12 over 13 PJ, and when I cross those through, I simply get 24 over 13 P times R in the K. And I get this because I see that I cross I gives no contribution, and so the only thing we get there is from the I cross J. We do a moment about the center of the disk. So in that case, the vector goes from O to the point of application, which is D, crossed with P. That is simply minus Ri, and P again was the 5 over 13 Pi minus 12 over 13 Pj. And so R cross F in this case gives us 12 over 13 P times R in the K. Let's see if those make sense. And what I mean by sense is, does the sign make sense? In each case, the moment was in the positive K. Can we reason that out by looking at the figure? We can see here that P, we can think of that as being broken up into our X and Y components that look like this. If we're looking about finding the moment about point A, we see that this force here will cause a moment in the positive K direction, R cross F, whereas this force will be a minus. And that's really what we saw down here. There was a plus part and there was a minus. It turns out the plus part was bigger, so that's why it gave it a plus. On the other hand, when we're looking here at point B, this part here does not make a contribution to the moment about B, only this one here does. And that R cross F is going to give us a positive K. And that's exactly what the math said. And then coming over here to O, it's the same thing. The X component of P makes no contribution because it acts through O. And the Y component again gives us a positive K. So it was a matter of writing first P out in terms of X and Y components. And in each case, A, B, and C, writing down the right R vector, going from the point that we want to find it about. And I think I said this right, but I think I wrote it down wrong. So for the moment about A, no, that's right. That's right. It has to go from the point of application to the, I'm sorry, one more try here. For the point about which we want the moment to the point of application. So we want to go from A to D in the first case, A to or B to D in the second case, and O to D. We want to find the moment about O with the load acting at D, and that gives us the directions that we need. Apologies for the initial thought that I had written it down wrong. Anyway, R cross F, that gives us the moment.